Hello everyone. Today we will discuss the unit circle, the definition of trig functions, and the fundamental trig identities. If we have a triangle, right triangle with an angle theta defined, the opposite side to theta, the adjacent side to theta, and the hypotenuse of the right triangle, we can define as 6 trig functions or trig identities as sine of theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, tangent of theta is opposite over adjacent, cosecant of theta, which is the reciprocal of sine, is hypotenuse over opposite, secant of theta is 1 over cosine, a reciprocal of cosine, which is hypotenuse over adjacent, and cotan of theta is 1 over tan theta, that's adjacent over the opposite side. Now, previously, you may have learned of this trig identities as SOHCAHTOA for the sine, cosine, and tangent, just as a way for you to have remembered it. Now, let's apply these ideas to the unit circle. In the unit circle, the circle is centered at the origin and the radius is 1. It means all the points on the circle satisfy x squared plus y squared is equal 1. We look at this right triangle here with the side x and y. It's the same as the unit right triangle. In relation to the unit circle, these ratios or the trig ratios become sine of theta is opposite over hypotenuse, which is y over 1. That's just y. Cosine of theta adjacent over hypotenuse, that's x over 1. And that's just x. Tan of theta is y over x, and it's the same as sine of theta over cosine of theta. Cosecant of theta, again, is the reciprocal multiplicative inverse of sine, that is 1 over y. Sine of theta is 1 over cosine of theta, or 1 over x. Cotan of theta is adjacent over hypotenuse, which is 1 over tan theta, or cosine theta over sine theta. If x squared plus y squared is equal to 1, this is the same as cosine theta squared plus sine theta squared equals 1. Because cosine was your x, cosine of theta was x, and sine of theta was y. It is usually written cosine squared theta plus sine squared theta is equal to 1. Let's look at an example. The point negative radical 3 over 2 1/2 is on the unit circle. Find the 6 trig identities associated with positive angle theta. Now your x value here is negative root 3 over 2, so let's check that. Those give you 1. Radical 3 over 2, square that, plus 1/2. Let's square that again. That will be equal to 3 over 4, because negative times negative gives a positive, plus 1 over 4, and that equals 1. So we check and we're done. Now let's find the 6 trig identities. Now we know that the sine of theta is our y value, so that will be equal to 1/2. Cosine of theta equal to our x value on the unit circle, that's negative radical 3 over 2. The tan of theta is going to be the sine of theta over the cosine of theta, that's 1/2 divided by negative radical 3 over 2, which will become negative 1 over radical 3. And if you want to, what we call rationalize the denominator, multiply both the top and bottom by radical 3 over 3, and that will give us negative radical 3 over positive 3. Okay, that is a way of making our denominator positive. Okay, now the cosecant of theta is the reciprocal of sine, that's 1 over 1/2, that would become 2. The secant of theta is going to be 1 over negative radical 3 over 2, so that would be 2 over negative radical 3. And if we want to rationalize this, again, we multiply both top and bottom by radical 3 over 3, and that will give us negative 2 radical 3 over 3. Okay, I meant radical 3 over radical 3 there. And then the cotan of theta is going to be 1 over tan of theta, which is going to be 1 over radical 3. So that would, and by the negative, so that will simply give us negative radical 3. Okay? So that's our 6 trig functions. Alrighty, let's look at a couple of other examples. Suppose arc length S is equal to 7/8 times 2 pi, that's 7/4 pi, or 7 pi over 4. What are the sine and cosine values of the angle? Well, we don't have the coordinates here, so we got to figure out what could the coordinates be. Let us sketch the unit circle real quick. And let us go an angle of 7 pi over 4, and let us see how far. So each of these is a pi over 4 cut. And we're going to do 7 of these, so let's make pi over 4 cuts on these. Okay, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, then 5 pi over 4, 6 pi over 4, and then 7 pi over 4. So this angle right here, we've made 7 pi over 4, right? So this is 7 pi over 4. All of this is 7 pi over 4. Okay, now we want to find what are the x and y values here. We don't know. But let's look at the relation between x and y. We know on this line, this is a line y equals negative x. So we know the relation that one is a negative of the other, right? So let's do x squared plus y squared is equal to 1. Then plug in negative x for y. So x squared plus negative x squared is equal to 1. Negative x squared is the same as x squared. So x squared plus x squared equals 1. So 2x squared equals 1. So x squared will be equal to 1 over 2 if we divide both sides by 2. So x will be equal to plus or minus the square root of 1/2. But because we're in the quadrant, the fourth quadrant, the x is positive. So we choose x is equal to radical 1/2 because we're in Q4. We are in Q4. Okay, if we want to rationalize this, let's go ahead and rationalize this. This is the same as 1 over radical 2. We rationalize by radical 2 over radical 2. That becomes root 2 over 2, right? So then the x value is our cosine value. So x is the cosine theta. So cosine of 7 pi over 4 equals radical 2 over 2. Now we know that y is equal to negative x. So y would be equal to negative of root 2 over 2. And we know that our y is the sine theta on the unit circle sine theta. So sine of theta is equal to negative root 2 over 2. Okay, next question. Suppose a real number t corresponds to the point P, negative 2/3 and negative root 5 over 3 on the unit circle. So our x value is negative 2/3 and our y value would be negative radical 5 over 3. 6 trig functions, let's do it. Sine of theta is our y value, so that's negative root 5 over 3. Cosine of theta, so x value, which is negative 2/3. From this, we can find our cosecant of theta, which is just 1 over sine of theta, so that's 1 over radical 5 over 3, negative radical 5 over 3, that's negative 3 over radical 5. We want to rationalize that by radical 5 over radical 5. And so we end up with negative 3 radical 5 over 5. Okay, the secant of theta, which is the 1 over cosine of theta, so that's going to be negative 3 over 2. Tan of theta, which is sine theta over cosine theta, so it's going to be negative radical 5 over 3 divided by negative 2 over 3. And so that tan theta will be, flip the 3 over and 2, so it's going to be negative radical 5 over 2, right? And then the cotan of theta is going to be equal to 1 over tan theta, so it's going to be 2 over radical 5. It's a negative. We want to rationalize that, so we go by radical 5 by radical 5, and so this becomes negative 2 radical 5 over 5. And that is your tangent. Let's look at another example real quick. If I walk around the unit circle in an anticlockwise direction, so I'm walking around the unit circle anticlockwise, and my x-coordinate is negative 1/2. So there I go, negative 1/2 and the y. And we know that x squared plus y squared is equal to 1. So negative 1/2 squared plus y squared equals 1. So 1/4 plus y squared equals 1. So y squared will be equal to 1 minus 1/4. It's going to be 3/4. So y, take the square root of both sides, will be equal to plus or minus radical 3/4. But because we are in Q2, then our y will be positive, so y will be equal to plus 3/4 plus radical 3/4, which is radical 3 over 2. So we found y, and we have x, and so we want the sine, cosine, and tangent. So our cosine theta will be equal to the x value, which is negative 1/2. Our sine theta is our y value, which is equal to radical 3 over 2. So our tan, which is our sine over cosine, so tan theta is equal to radical 3 over 2 divided by negative 1/2, which is going to be equal to negative radical 3. And that's our answer. Okay, now let's look at another example. I walk around the unit circle in anticlockwise direction, and I go a distance of 7 pi over 2 units. So let's, this distance is pi over 2. We want to go 7 of these. So 1, 2, 3, 4, 5, 6, and 7. So we are right here. So we are right on this line. So this is where 7 pi over 2 is. 7 pi over 2. Right, so that's where 7 pi over 2 is. So what are the x and y coordinates there? What are the x and y coordinates there? The x and y coordinates at that point, x and y, or x will be 0 and our y will be negative 1. X will be 0 and our y will be negative 1. So the sine of 7 pi over 2 is our y value. So our y value, which is negative 1. And the cosine of 7 pi over 2 is our x value, which is 0. Tangent of 7 pi over 2 is our y value, which is negative 1, over x value, which is 0, but it's not defined, or does not work. So not defined. And so that's our sine, cosine, And our tangent values, sine is -1, cosine is 0, the other one